Ну что, по стандарту проверяем звук, проверяем трансляцию. Сейчас, одну секунду. Так, какая-то херня. Да. Чихнуть хочу. Ух. Жесть. Так. Window functions.
Great job. You now have experience transforming data using simple subqueries, correlated subqueries, and common table expressions. Let's tackle another limitation you've likely encountered in SQL, the fact that you have to group results when using aggregate functions. If you try to retrieve additional information without grouping by every single non-aggregate value, your query will return an error. Thus, you can't compare aggregate values to non-aggregate data. You can work around this limitation using a window function. Window functions are a class of functions that perform calculations on a result set that has been already generated, also referred to as a window. You can use window functions to perform aggregate calculations without having to group your data, just as you did with a subquery in Select. You can also use them to calculate information such as running totals, rankings, and moving averages. So what's a window function? How do you use it? Let's start with a query from Chapter 2, where we answered the question, how many goals were scored in each match in 2011, 2012, and how did that compare to the average? This query selects two columns from the match table and then used a subquery in Select to pass the overall average along the data set without aggregating the results. The same results can be generated using the clause common to all window functions, the over clause. Instead of writing a subquery, calculate the average of home goal and away. And follow it with the over clause. This clause tells SQL, pass this aggregate value over the existing result set. The results are identical to the previous statement that used a subquery in Select with a simpler syntax and a faster processing time. Another simple type of column you can generate with a window function is a rank. A rank simply creates a column numbering your data set from highest to lowest or lowest to highest based on a column that you specify. Let's take the same query as the previous example without the window function and use it to answer the question, what is the rank of matches based on the number of goals scored? We can answer this using the rank window function. In order to set this up, let's add a new column in Select as you see here. To create the rank, you start with the rank function using parentheses followed by the over clause. Inside the over clause, include the order by clause and the column or columns you want to use to generate the rank. By default,
Секундочку. Посмотрим на Postgres. Window function. Postgres rank function. Что это такое вообще? Rank, over. А у нее здесь тоже over. The function assigns a ranked... блять, нет, лучше это я переведу, потому что хер не знаю. Функция rank присваивает ранг каждой строке в разделе результирующего набора. Ага. Просто номера дает. Ну окей. Окей. Кстати, очень хорошие. Сейчас скину ребятам. Postgres Tutorials. Руководство. Да, шикарно.
The rank function orders the results and ranking from smallest to largest values. In the case of our data set here, this isn't particularly informative. You can easily correct this by adding the descending function to reverse the order of the rank, just as you would if you were using order by at the end of your query. You'll notice that the rank function automatically ties identical values, such as the first two results function.
Automatically ties identical. Блять. Вот это вот обожаю. Вроде знакомые слова, а ни хрена непонятно. Автоматизированные галстуки, что это? Автоматически связан. Все, извиняюсь. Identical. Все.
Automatically ties identical values, such as the first two results, and then skips the next value in the rank. There are a few key considerations when using window functions. First, window functions are processed after the entire query, except the final order by statement. Thus, the window function uses the result set to calculate information, as opposed to using the database directly. Second, it's important to know that window functions are available in PostgreSQL, Oracle, MySQL, but not in SQLite. Okay, let's practice some simple window functions using the over clause.
Погнали. Вот ты, конечно, батишь на звездочки. Select the match ID. Select country. Select the match ID. Match ID. MID. Country name. Name. Country name. Season. Home and way ago. Хорошо. M. Use a window to include the aggregate average in each row. Complete the query. То есть что? Complete the query that calculate the average number of goals scored overall, and then includes the aggregate value in each row using a window function. Используя оконную функцию, но я здесь не вижу оконной функции. Я просто вижу типа AVG надо использовать. mHome плюс away goal. Over. Это типа надо over написать. Сейчас посмотрим, как правильно пишется. То есть вот. S, окей. What is the window function? What is the window function from match? Over. Ну просто over надо написать, да. Все. А что не то? А что не то? А что не то? Ничего не то. Сейчас посмотрю внимательно. Я вроде правильно написал. Запятая. АВГ. С. Не. Ну, все работает. В чем проблема? Что не так? Ты опять сейчас напишешь? Нет. Окей. Так, хорошо. Select the legal name and average. То есть legal name, L name. Liga as L name. Хорошо. And average total goals scored from Liga and match. АВГ. Так. М. Home goal. М. Away goal. Rank. Over, да? Rank over. Правильно? Не, надо будет смотреть все-таки на конспект, потому что непонятно. Rank over order by. Не, все верно. Order by M. Order by the query. Average total of home and order the by. Так, сейчас. Order the rank by the average total of home and away goals scored. Liga rank. Да, чё? Чё не то? Over. Sorry. Вот так, over, то есть это у нас попадает, все, я понял, это rank, мы присваиваем ему ранг, а в over это как бы оконная функция. Ясно. Хорошо. Select the liga name, L name, and average goal scored, AVG, M home goal, rank, over, order by, rank, order average goals, AVG, M home goal, descending, order by legal rank. Что не так? Rank забыл написать. Over with partition.
You've done a great job working with the over clause so far. The real bread and butter of window functions that differentiates them from subqueries and select are in the functions you can add within the over clause. One important statement you can add to your over clause is partition by. A partition allows you to calculate separate values for different categories established in a partition. This is one way to calculate different aggregate values within one column of data and pass them down a data set instead of having to calculate them in different columns. The syntax for a partition is fairly simple. Just like before, use an aggregate function to compute a calculation, such as the average of the home goal column. You then add the over clause afterward, and inside the parentheses, state partition by, followed by the column you want to partition the average by. This will then return the overall average for, or partition by, each season. Let's take a look at how this works in a query. This example query from the previous lesson answers the question, how many goals were scored in each match, and how did that compare to the overall average? This is accomplished using the over clause, and the query returns the date, goals scored, and overall average. Let's expand on the previous question and instead ask, how many goals were scored in each match, and how did that compare to the season's?
Давайте мы перейдем сразу partition, потому что я ни хера не понимаю. Типа частичное что-то. Разделение, переборка.
Average. We can do this by adding a partition by clause to the over clause from the previous slide. Specifying partition by season returns each season's average on each row in accordance to the season that each record belongs to. As you can see, rows 1 and 2 are matches played in the 2011-2012 season, and the season average column contains the 2011-2012 season average. Rows 3 and 4 are part of the 2012-2013 season and return the 2012-2013 season average. You can also use partition to calculate values broken out by multiple columns. In the query you see here, the over clause contains two columns to partition the average goals scored, season and country. The results set returns the average goals scored broken out by season and country. In row 1, a match was played in Belgium in the 2011-2012 season and had 1 goal scored throughout the match. This is compared to the value 2.88, which is the average goals scored in Belgium in the 2011-2012 season. Partition by is a pretty straightforward addition to the over clause. You can partition calculations by 1 or more columns as necessary to answer a question you may have. Additionally, you can use a partition with any kind of window function, a calculation, rank, or others that we will discuss further in the following lesson. For now, let's practice calculating window partitions on our match data.
Complete the two window functions that calculate the home and away goal averages. Partition the window functions by season to calculate separate averages for each season. То есть мы выбираем дату, season, home goal, away goal, case, when. Else, ё-моё. Calculate the average goals scored partitioned by season. Filter the query to only include matches played by Liga Warszawa ID 8673. Filter the data set for Liga Warszawa. Match only. Match only у нас Warsaw. ID 8673. Filter the dataset for Liga Warszawa. Dataset. Хрен его знает. Так. Что у нас тут? А тут у нас calculate separate values for different categories, calculate different home goal over partition by season. Goal scored partition by season. VG match. Отфильтруйте запрос, чтобы включить только матчи, сыгранные. Короче, я понял, кажется, все, я понял. Леджия Варшава. Сейчас. Home. Ну, что такое? Home Team ID 8673. Ну, так что ли хочешь? Ладно. Давай-ка мы вот это вот сейчас скопируем. Вот так. В принципе, вот так, наверное, хочет. Да? Team long name. Леджия Варшава. В чем проблема? Есть тут. Пока не вижу. Home team ID. Check the high code. The checker expect to find home team ID 8673. Ну. Окей, вот так. Хочешь так, что ли? Нет. Проверьте выделенный код. Проверяющий ожидал найти Home Team ID 8673. Хорошо, давай посмотрим. На. Ну и что? И что? И что? Нет. Этого нет. To only include matches played by Liga Варшава. Home Team ID 8673. Варшава. Played. И все. Away Team ID. Не то вводил в итоге. Construct to window. Так, сколько мы сделали? 40%, хорошо. Construct to window function partition the average of home and away goes by season and month. Calculate average goals partition by season and month. Extract month. Тут month. Partition by season. Partition by season over AVG 86-73 673. Погнали дальше. Sliding window. То есть в смысле sliding window? Это типа нарезка, раздвижные окна. Прикольно. 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 Вот это что-то новенькое.
In addition to calculating aggregate and rank information, window functions can also be used to calculate information that changes with each subsequent row in a dataset. These types of window functions are called sliding windows. Sliding windows are functions that perform calculations relative to the current row of a dataset. You can use sliding windows to calculate a wide variety of information that aggregates one row at a time down your dataset. Running totals, sums, counts, and averages in any order you need. A sliding window calculation can also be partitioned by one or more columns, just like a non-sliding window. A sliding window function contains specific functions within the over clause to specify the data you want to use in your calculations. The general syntax looks like this. You use the phrase rows between to indicate that you plan on slicing information in your window function for each row in the dataset. And then you specify the starting and finishing point of the calculation. For the start and finish in your rows between statement, you can specify a number of keywords as shown here. Preceding and following are used to specify the number of rows before or after the current row that you want to include in a calculation. Unbounded preceding and unbounded following tell SQL that you want to include every row since the beginning or the end of the data set in your calculations. Finally, current row tells SQL that you want to stop your calculation at the current row. For example, The sliding window in this query includes several key pieces of information in its calculation. It first states that the goal is to calculate the sum of goals scored when Manchester City played as the home team during the 2011-2012 season. It then tells you that you want to turn the calculation into a running total ordered by the date of the match from oldest to most recent and calculated from the beginning of the data set to the current row. Your resulting data set looks like this, with a column calculating the total number of goals scored across the season, with a final total listed in the last row. Using the preceding statement, you also have the ability to calculate sliding windows with a more limited frame. For example, the query you see here is similar to the previous one with a slightly modified sliding window. The phrase unbounded preceding is replaced here with the phrase one preceding, which calculates the sum of Manchester City's goal in the current and the previous match. As you see in the data set here, the two rows in red are used to calculate the sum on the second row, and the two rows in green are used to calculate the sum on the third row. There are a wide variety of sliding window calculations you can use to calculate information in your query. Let's practice here with some examples based on what we reviewed so far.
Ни хера непонятно. Смотрим дальше. Что у нас? Create a running total and running average of home goals. То есть, complete the window function by assessing the running total of home goals scored by ascending running average ordering both the running average and running total by date. Хорошо. Типа сортировать их по дате. Где это data? По времени. И агрегировать типа. Хорошо. Slide to the left. Sliding window allow you to create running calculation between any 2 points in a window using functions such as preceding, following, and current row. You can calculate running counts, sums, averages, and other aggregate functions between any 2 points you specify in the data set. In this exercise, you will expand on the examples discussed in the video, calculating the running total of goals scored by the FFC Utrecht when FC Utrecht, хрен его знает, как называется, when they were the home team during the 2011-2012 season. Do they score more goals at the end of the season as the home or away team? Пойми вообще. Perform calculating, preceding, following, is ascending. То есть, что у нас? Sum, over, order by, date, rows between. Хуй пойми вообще. Ладно. Home goal, away goal, create a running total and running average. Короче, тут у нас sum, тут у нас AVG, over, over by date between preceding, following and current row. То есть мне надо так написать. Preceding. Блин, как оно? Preceding row between following current row. Ни хрена непонятно, если честно. Почему и зачем это надо? Ну ладно, посмотрим. Rows between and bounded. Preceding. Хорошо. Rows. Строки между неограниченными предыдущей и текущей строками. Select the date. The date, home goal, away goal. Away goal. Create a running total and running average. Ну хорошо, здесь у нас sum. Тут у нас AVG. Over. Descending. Order by date. Order by date. Between. Over. Ordering both the current row from the current row to the end to the data set between total of home goals scored of duck running average, ordering both the running average and running total by date descending. Так а что хотите-то от меня? Unbounded. Опять вот так, что ли? Только в обратную сторону. Current. Все. Current row and embodied following. Наоборот. Я что-то подумал сначала так. Но подумал, ну его нафиг. Embodied preceding. В чем проблема? Rows between current row and unbounded following. Господи. Bringing it all together. Congratulations.
Congratulations. You made it to the final lesson of the course. Throughout the course, we've covered a wide variety of methods for transforming, manipulating, and calculating data to answer a wide variety of questions in SQL. Specifically, you learned how to use case statements for categorizing, aggregating, and calculating information, and how to use simple subqueries in select, from, and where clauses. You also learned how to use nested and correlated subqueries and common table expressions to extract, match, and organize large amounts of data in order to generate a final table. Finally, you learned how to use some of the many window functions available to you in SQL. Let's put several of these topics together to answer one question about your
Еще один
dataset.
case study.
Who defeated Manchester United in the 2013-2014 season? In the following exercises, you will generate a dataset that tackles one of the issues we've explored during this course, namely that it's difficult to retrieve the names of teams who played in a given match. Since this isn't feasible with joins, we will accomplish it with common table expressions. We'll also be using case statements to categorize the outcomes of matches based on whether or not Manchester United won a particular match. Finally, we'll be ranking matches by the number of goals they lost a match using a window function. If Manchester United happens to be a team that you favor, or if there are any other European teams you consider a rival to your favorite team, I encourage you to explore the European Soccer Database for yourself and create similar or completely different queries to answer your questions. Okay, let's get to it.
Сложно. Что-то очень сложно. Create a case statement. Case when m whole m away goal, then хорошо, when away goal, then else and from match left join team team ID API и team ID and team API ID. Team, блять, где это? Team API ID. Team API ID match. Просто хорошо. MID. Filter. M. Season. Из 2015. Manchester United. M home team ID. Хорошо. Home team ID. Окей, вот так. Season. The checker expect to find. Ну так я же набрал. M season. Не понял. Season. Господи. Case. Identify matches. Case. When. Меньше. M. Wiggle. Ой. Стой. When. Complete case statement syntaxes. Fill out the logical operator. Identify each match as a win, loss, or tie Manchester United. Join the table. Ну. Ну все верно я написал. When we go, else, and match team away team, извиняюсь. Away team ID and team ID IP, хорошо. А тут у нас что надо фильтровать? Manchester United. else tie. Then пропустил. Все, вот. Column ID seems to be incorrect. MID. А в чем проблема? Away team ID and join the table on away team ID and team ID IP. Окей, хорошо. Что, вот так надо? Окей. Declare home and away. Ой, ёпта. With home as away as select distinct select the relevant data from Господи, select distinct у нас какой? У нас distinct team names. Team long name. The date and goals. Home team. Select the date from match. From match. Home team ID. Away team ID. И team long name. Окей, хорошо. From match as. Join the city onto the match table. Ого, вот это, блядь, вообще просто пиздец. Выберите дату из матч, название команд, из сети, и голыми дома в гостях, блять, и голы дома в гостях из матч основного запроса. Left, home, away, mid, home, no operating matches, m, home team long name, team long name, хорошо. Away, team long name, жесткая херня. Блять, тут rank over order by descending data home team ID away team long name left join home ID away ID left join away. Пиздец. Просто select the end date. Монакай. Что это такое вообще? Потрясающе. Это интересный список совпадений. Вы можете легко изменить этот запрос для любой команды по вашему выбору. Наконец, если вам понравился этот курс, сообщите, написав. Сохраним сейчас. Хорошо. Так. Ну-ка. Нет, это не та. Господи. Ой, господи. Что-то непонятно. Ладно, хрен с тобой. Так. Ну что, мы закончили? Да, мы закончили. Все, всем спасибо. Продолжим чуть позже.